because now it's time for our amazing Julia Lorenz. She's from the Leibniz Institute for Zoo and Wildlife Research. She's part of the citizen science project Fledermausforscher Berlin. I hope I said it right, where they monitor urban bats in this amazing city, Berlin. She's gonna talk now about fantastic bats and how to hear them. So, Julia, the floor is yours.
Thank you, Marta, for introducing me. Hi, everybody. My name is Julia Lorenz. I'm working at the IZW, and I'm in the citizen science project Fledermausforscher Berlin. And my job is actually to guide citizen scientists to make mobile studies with bats. And I'm going to show you how this is done and how we can hear bats and how to figure out which kinds of bats are living actually in Berlin. So first of all, why are bats so fantastic? So for me, when I first studied bats and came closer to the literature, I was amazed how many aspects were not aware to myself. Since I know they are nocturnal mammals, so they are flying in the night, I didn't know that they are actually existing worldwide, except for the polar regions and where it's very dry. So in Berlin, for example, we have 18 species out of 24 species which are present in Germany. When you look at the global scale, you have 1,400 species, and this number is growing constantly. And bats literally save us billions of dollars every single year because they are a great pest control. Specifically, if you go into the agriculture field and people using pesticides that shouldn't be using, bats would be there and they're eating off a ton of insects every single night. And they're key pollinators. So the video you just saw, this is a fruit bat. And it is a flying fox, a little bit bigger than the bats we have in here in Germany. And they are pollinating flowers and trees. And if they wouldn't do this, we wouldn't enjoy like something like tequila because they pollinate agave plants or they pollinate avocado plants. So for hipster Berliners, there wouldn't be any avocado toast to enjoy. Oh my God, yes. And they are also very different in size. So at the bottom, you see a tiny pipistrelle bat. It's literally this big, like a thumb, and you can put it into a tiny, tiny matchbox. And this is one very common pipistrelle here in Berlin. You can see fluttering around lamps every single night, especially at the time around June and July when the bats are very, very active. Okay. What the Chiroptera? So Chiroptera, it's literally the meaning of hand wing. So you see a bat wing and an arm and the fingers of a human. So you can see the bones have not the similar function, obviously, because we can't fly, unfortunately. But you see that we are really, really greatly related to them, although we can't fly. But you see how fragile those tiny, tiny bones are. But even though they are very, very fragile, this is actually a very, very great deal for bats because since they are so flexible and everything is so tiny, they can maneuver in flight way better than birds. And so they can make turns very, very quickly. And they do it in a way that we can't hear. We can see them turning like very, very crazy and fluttering around, but this is mostly soundless. There's a saying, blind like a bat. Well, I have to, disappoint you. Bats can actually see, and some fruit bats even have such an amazing view. They can even track down UV light because they need it to detect some fruits. So this is not a true statement. Obviously, in the nighttime, it is much darker, so they can't have a crisp, clear picture in front of them. So they try to use their niche and make the most out of it, not just trusting on their eyesight, but they hear. And how it's going to work is they emit ultrasound through their mouth or their nose, depending on species. And this sound gets reflected by prey or something, an obstacle like a tree. And then they make an audible picture of the environment, and they see in their head kind of where the prey is or where the obstacle is. When a bat emits a call, it is mostly out of our human hearing range. So it is above 220 hertz. So some kids are still able to hear because their ears are still fresh and not so destroyed like our grown-up ears, but still it is quite hard for them as well. But we can detect them. And how we're going to do it, we have a bat detector, and it is able to detect those ultrasounds. So if you have now your earplugs in or your computer audio on, I'm going to start the video, and you are now about to hear how bats sound like. I hope you heard it. Awesome, great. So this device has a little speaker in it and is like a real-time reflection of what a bat emits. But obviously it's really, really rough to say just from hearing which kind of bat was there. And it was dark in the park. You maybe didn't saw the shape of the bat. So it wouldn't kind of very professional to say, oh yeah, that was this kind of species. So what I'm gonna do next is I'm gonna take out the calls from the device and put them on my computer, where I have an algorithm which is checking if there was a bad call or not. And this would look like this. A huge mess. And all the yellow lines you see are bad calls, which were tracked down from the algorithm. And if I zoom in, I can see those little lines on the left-hand side. And in the middle, you can see the names of the bat species. And on the right side, you see the picture of those species. Those are all pipistrelle species. And they are calling in a different range. So the soprano pipistrelle is calling in a very high tone. The common pipistrelle is like in the middle located, and then Narcissus pipistrelle is a little bit down below. But you see, the shape is constantly the same. So I really have to zoom in into every call and see how long it is, at which frequency this call is ending, and also how long it takes where the next call is occurring. So all these things the algorithm can't do, I have to do. And yeah, this is how I make the calls visible and can say this specific bat was there. Sometimes those calls are overlapping, and then it gets a little bit more complicated. But in the end, the more calls I have, I can also work a little bit better, especially also the algorithm, which is also helping me in the background, will work better. Okay, I really hope you enjoyed the little talk about how fascinating bats are. And if you have some questions, then get them to me. And yeah, I really hope you have a nice evening.
So, wow, they're so cute. Now I want to hug a bat. I mean, it's really amazing. I was really wondering because I heard you talking about bats and recording them a lot, but I was always wondering, like, how would you actually get to it, like how you actually work with it. And we have here one question for you from Carolina. So how many different species are there in Berlin?
So in Berlin, we have 18 species. But you have to be very careful. It's not that these 18 species are present in Berlin at the same level. Some species are coping better with the city environments, and some species, they are very shy. They are living in forest areas where they have different set of insects they eat, and sometimes they're also very light sensitive, so they avoid city life.
Wow.
I have a question. Can I quickly ask one?
Yes.
What is your favorite bat? And do you have one? Because I
Yeah.
feel like everybody has a favorite.
So actually, here in Germany, there's one. It is a Plicoto species you saw at the very last slide, because they have very, very large ears, and it is quite hard to detect them as well. And every time I detect one, I'm so happy because all of them are threatened. So this species the most, because it really can't cope in a city environment. But if you find them, you have like it's like a good sign, because they're also bioindicators. And if you have this one Plicoto species there, I'm like, oh yes, amazing. There, everything is healthy, great.
Liliana asked if it's possible to distinguish individual bats based on their call, like whales and their fins.
Yeah, sometimes if you have a bat just in your hand, you can detect the species by the emitting calls, because sometimes, or not sometimes, there's actually a huge library of bat calls, and all scientists who are working in the bioacoustics fields are gathering all the files together. So you have a library, and then you can see, okay, in which range the bat was calling. So you can see, okay, that could be this bat. And sometimes they're also changing their tone, and also like kind of their the durability of a call. That makes it sometimes hard, but the more calls you have, the better the probability for you to detect which kind of species was there.
Okay, I mean, now we are out of time, but we have more questions for you. So later.